Good evening, Honors Algebra. This is your flipped lesson for Friday, November 18th. No, excuse me, this is your flipped lesson for Thursday, November 17th. My mistake. All right, hold on, let me change that date. I know I have to correct it, or James is certain to point it out to me at least 6 or 7 times. All right, today we are going to be learning about application problems. In other words, why have we been learning all about slopes and points and lines? We're going to show how they can be used in the real world. So I'm going to give you some problems. I'll read them to you. The words will appear on the screen, and then we'll show you how to break them down. Now, look, some of you heard story problems, and you're freaking out. Just calm down. They're not a big deal. You just got to learn that the key words, which ones tell you, hey, this is a slope, or that's a point, or something like that. It's not that hard. So let me get the first problem up. Okay, our first problem is a carpenter built a staircase. He wanted the ratio of rise to tread to be 2 to 3. If the actual staircase was 144 inches long, how high does the staircase reach? Now, if you stop and think about this problem, there's some keys words going on here. For example, we see this word here of rise. That sounds really familiar. I think if you actually talk to a carpenter, they would call it the riser. Okay, the riser in a staircase, here's my stairs, shoom, 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 shoom. Okay, the riser is this part here. Let me change color so you can see this right here. That's the riser. How much it's going up. All right, and then it says compared to a ratio of the tread. Well, tread is kind of where you step. I would think that the tread must be this part, the tread. Yeah. So when I see this, I go, oh, it's a rise and run problem. In other words, go on, fill in the blank. It's a blank problem. Hopefully you said slope and not blank. So I know that my slope needs to be 2 to 3. Rise 2, run 3. Rise 2, run 3. I also know that the actual staircase runs, because it's 144 inches long, it runs for 144 inches. 2 clicks like that means inches. And then I need to know how tall the staircase is. That's my variable. You know what? Maybe I won't use x there because that'll confuse people. Maybe I'll use the change in y. Yeah, that's it, because the y's rise to the top. Sorry for using x. I don't want to confuse anybody. It's just that, in pre-algebra we use x for just about everything. All right, well, this is just a simple proportion, and this is the one time in math you are allowed to tell me to cross multiply. Please never tell me to cross multiply any other time. So I'm going to get 3 times the change in y, and that's going to be 288, right? And by the way, just a little math trick for you. What's 2 plus 8? Plus 8? It's 18, right? Does 3 divide evenly into 18? It sure does. Therefore, 3 goes into 288. That trick works for 3s and 9s. If you add up the digits of the number and you get a multiple of 3, then 3 will divide into it. If you add up the digits of a number and 9 will go into it, into the sum, then of course 9 goes in. 9 will go into 288 because 9 goes into 18. By the way, if you weren't sure if 3 went into 18, you could also continue go 1 plus 8 and get 9, and then 3 does go into 9. All right, enough about that. Pardon me. 3 is attached to the delta y by multiplication. I will divide to undo it. I will divide over here. So my change in y, or how high the staircase must go, is going to be the same as 288 divided by 3. So 28 divided by 3, I think it's going to be 92 inches tall. 92 inches doesn't mean a whole lot to me, but if I divide 92 by 12, or I can even go old school long division. Well, let me see there. I don't think 8's going to work. 7 would be good. 7, we're going to get a 4. We're going to get an 8. So 7.6 inches, what was that, 72? And that's 80 is going to repeat. It's going to be 7 2/3 inches, right? Yeah. Um, 7 feet and 7 2/3 feet. I just converted it to feet, excuse me. So 7 feet. Now, that's one mark for feet. And 2/3 of a foot. What is 2/3 of 12? Well, 1/3 would be 4, so that would be 8 inches. Just a little conversion for you there. The important part is reading the story and realizing, hey, it's just a slope problem in disguise. All right, let's move on to the next problem. Okay, Matt is selling tickets to the music program at school. Elisa has enough money to buy 9 student tickets and 2 adult tickets, or she could buy 3 student tickets and 6 adult tickets. Write an equation to explain this situation. Now, this is actually pretty cool because this story problem has everything in it that you need to answer the question. See, the trick is you've got nine students in this problem, and in this situation you've got 3 students. But over here you've got 2 adults and 6 adults. What do you think? I'm thinking points. I'm thinking that I have 2 points right here. I have the point 9, 2, and I also have the point 3, 6. Okay? What I did was I let the 9 be my x coordinate. So in other words, x is the number of student tickets. X equals the number of student tickets. And therefore y must be the number of adult. Better fix that. Adult tickets. There we go. Okay. If I know the 2 points, I can find the slope. If I can find the slope and I have a point, I can write the equation in point-slope form. I can write it in slope-y-intercept form, and I could even convert it to standard form. And I'm going to do all 3, and you're going to see why in a minute. Okay, so first of all, let me find the slope here. Slope is going to equal 6 minus 2 over 3 minus 9. All right, I'm going to get 4 over negative 6, or negative 2/3. I'm going to start off in point slope form because it's the easiest way to just get one of the equations written. So I'm going to write my equation in point slope form. So I will pick the point 3, 6. Okay, so y minus 6 is going to equal negative 2/3 times the quantity of x minus 3. There's my point slope form. That's done. It doesn't really tell me much except a point and the slope. All right, I'm going to convert it to slope y-intercept form and see what happens. All right, so I'm going to convert this to slope y-intercept form. So y minus 6 equals negative 2/3 x plus 2. And then I still have to add 6 to each side. Okay, and y will equal negative 2/3 x plus 8. Let me see here. So this is, I should label these. This is point slope form. And this one here is slope y-intercept form. And I noticed that the y-intercept is 8. I think that would mean, correct me if I'm wrong, but I think that would mean that if Elisa buys 0 student tickets, she should be able to afford 8 adult tickets. I think that's what that would mean, because I let y equal the number of adult tickets. And the y-intercept, the coordinates of this point, are 0, 8. So if there are 0 student tickets purchased, there are 8 adult tickets purchased. Okay, I'm just showing you this so that you can see how much information is contained in a story problem. All right, we're going to scroll down here again. And now I'm going to convert this to standard form. And let me see, the first thing I'm going to do is I'm going to add 2/3 x to each side. And that's going to equal 8, right? I did plus 2/3 x plus 2/3 x. And I'm in standard form because I'm in ax plus by equals c form, except the 2/3 doesn't really mean anything to me in the context of the problem. I think I'm going to make it so that my standard form has only integer coefficients. In other words, I'm going to get rid of the fraction. I'm going to multiply each term by either 3/1 or 3. And that will get rid of my fractions for me. Now watch what happens. This is pretty cool. Okay, I'm going to get 2x plus 3y, and that's going to equal 24. So now I am definitely, this is standard form, and we say with integer, remember z is a symbol for integer, coefficients. All right, so standard form with integer coefficients. Okay, so here's the cool thing. Oops, sorry, that scrolled on you there. So here's the cool thing. You see this number right here? This one? That could be the money that Elisa has to spend on the tickets. This is the price of the student ticket, and the 3, the coefficient of y, is the price of the adult ticket. All from some basic equations that you already know. Okay, this is pretty powerful stuff. Now, in class on Friday, we're actually going to practice these things, but I wanted to expose them to you in this video. Class on Friday, you're just going to be exploring parallel and perpendicular and actually graphing some of the equations. Unfortunately, I won't be there. I'm at another meeting at the board office. It's an all-day meeting, so I won't be able to stay after school and help. But I trust that you guys have watched the parallel perpendicular video. You got practice Thursday in class. You will get practice Friday in class. Now, over the weekend, the video will be review type lessons, making sure you're ready for Tuesday's test. If at all possible, I know some of you have told me that you're not going to be there Monday or Tuesday, something like that. But if at all possible, don't be absent Monday or Tuesday next week, because you want to take that test before the break. It just would be a better thing. I mean, if you can't help it, you can't help it. But anyway, so after Thanksgiving, we'll be getting into some application problems, and you'll see how useful this stuff is. But I felt like it was a good time to put in an application video. All right, this is Mr. Lawrence signing off, and I will see you next time. Au revoir.